Assalamu alaikum. Welcome to UMT Massive Open Online Course. I am Siti Aisha Abdullah from the School of Marine and Environmental Sciences. I am a marine biologist, more specifically, a marine botanist doing work mainly on seaweeds and seagrasses. Estuaries are very dynamic ecosystems that provide many important benefits to humans. We will be looking at these benefits today. Within the estuaries, we have mangrove forest. For this part, we will focus on mangroves, and by the end of this lesson, we should be able to identify the benefits people get from estuaries and mangrove ecosystems, ecosystem services, and understand how these ecosystems are able to provide these services and to classify these services either as regulating or supporting services. We will start with the definition of ecosystem services, followed by classification of ecosystem services. The Millennium Report in 2005 defined ecosystem as a dynamic complex of plant, animal, and microorganism communities in the non-living environment interacting as a functional unit. We humans are an integral part of the ecosystem. Ecosystem services are the benefits people obtain from ecosystems. These services enhance human well-being. Among these services that contribute to people's ability to mitigate and adapt to the impacts of climate change. Ecosystem services are classified into four. Supporting services are services necessary for the production of all other ecosystem services, such as photosynthesis and nutrient recycling. Regulating services are benefits obtained from the modulation of ecosystem processes such as climate regulation and water quality control. Provisioning services are products obtained from ecosystems, food, water, timber, or fiber. Cultural services are non-material benefits obtained from the ecosystem, such as recreational, aesthetic, or spiritual benefits. In this lesson, we will be looking at supporting and regulating ecosystem services. Before we go to specific ecosystem services, we need to look at the most fundamental process that starts it all, photosynthesis. Remember the topic on biotic communities in the estuary? We know that already. Mangroves are the main primary producers in the tropical estuary. Here is a mangrove tree with a green pigment chlorophyll in its leaves. It captures sunlight that drives the process of photosynthesis. Carbon dioxide is taken from the atmosphere. Water and nutrients from the soil are taken up through the roots and are converted into organic matter, organic carbon, in the leaves. Stored carbon are products of photosynthesis and are the food used by this tree to run its metabolism and build up its leaves, branches, fruits, flowers, and others. The tree grows, ages, reproduces, becomes tall, heavy, and bulky. It's not only the above ground structures that grow, but the roots below the ground too. So, carbon dioxide from the atmosphere has been converted to organic carbon stored for years to decades as above ground biomass and below ground biomass of the mangroves. Sequestered carbon daily and as the tree ages, leaves and other parts fall onto the sediment surface. This is known as leaf litter. This starts to break down, forming detritus, which many organisms feed on. Detritus composition is low because of the low oxygen levels in the sediment. Hence, this organic carbon plus the original below ground biomass stay in the mangrove sediment for a very long period of centuries to millennia. This is sequestered carbon. Coastal blue carbon. The carbon stored and sequestered by the mangroves are part of coastal blue carbon. The total carbon stored in all primary producers of the coastal estuarine areas is known as blue carbon. Remember, supporting ecosystem services are services that allow other ecosystem services to happen. First, the organic matter produced by primary production is the food that supports various consumers, including humans. It is the base on which all other organisms in the mangrove food web depend on. During photosynthesis, oxygen is released as a byproduct. This oxygen is the 21% oxygen in our atmosphere gas that we inhale every time. This is vital for life. Half of all oxygen on Earth is produced by blue carbon. Nutrient cycling. Second, we have seen how mangrove trees take up nutrients such as nitrogen and phosphorus for use in organic matter production during photosynthesis. Leaf litter that are ultimately decomposed, organic nitrogen and phosphorus are converted back to inorganic forms that are used again by the trees. This ecosystem service is nutrient cycling. This effective nutrient cycling results in high productivity in spite of the generally low nutrient levels in mangroves. Third, in our earliest discussion on estuaries, we have seen how water currents from rivers carrying suspended particles slow down as they pass their roots. These particles settle out of the water and form layers of non-organic sediments over time, resulting in vertical accretion. This is soil formation from materials originating outside of the estuary. However, mangroves also contribute to vertical land building by organic sediment formation or peat formation of its below-ground components, the roots. Some studies have shown that the increase in surface elevation matches the predicted sea level rise resulting from global warming, thus ensuring continuity of mangrove habitats and the ecosystem services they provide during the era of climate change. Habitat provision. Fourth, the high productivity and rich organic materials produced by mangroves and lower number of predators are believed to be the main causes for mangroves acting as nursery for a diverse community of juvenile fish and shrimps. However, this nursery function may be possible due to habitat connectivity, where other resources and functions are provided by nearby seagrass beds and coral reefs, as shown in the life cycle of this grouper. Habitat provision. The trees, sediment, and water also serve as habitats for the various biota of the mangrove forest. The habitats may be permanent or temporary for residents or stopovers for transient species such as migratory birds. Now, we have seen the supporting services which are basic and must be there for the other ecosystem services to be delivered, and the benefits obtained are direct and on a long-term basis. Among the ecosystem services that are supported by these are the regulating ecosystem services. Regulating ecosystem services are able to lessen the impacts of man-made activities such as pollution or from natural disasters. The present problem of global warming is caused by the excessive amount of carbon dioxide in the atmosphere added by human activities. As a result, climate change is occurring at different levels that are threats to our well-being, including security in terms of food, water, health, safety, and others. Different methods are being looked at to reduce atmospheric carbon dioxide. First, during photosynthesis, carbon dioxide is removed from the atmosphere, converted to organic compounds, and ultimately stored and sequestered as coastal blue carbon. Measurements have shown that mangrove forests have the highest or among the highest carbon storage and sequestration capability. That is, much better than the terrestrial plants or forests. Therefore, mangroves are very important in climate regulation and mitigation through carbon storage and sequestration, ultimately lessening the dreaded effects of climate change and global warming. Second, during photosynthesis, mangroves not only take up nutrients and water from the surrounding soil. Mangroves also take up pollutants carried into the estuary by river inflow. Water purification through pollutant assimilation and nutrient filtration cleans up the water before it leaves the estuary and enters the coastal areas. Before and after tsunami of the West Java in 2006, disasters of previous years such as tsunamis and typhoons have shown that the belt of mangroves growing between villages and the open sea protected these areas from greater damage and higher loss of lives. Coastal protection by wave attenuation is considered as one of the most important and valuable ecosystem services provided by mangroves. Coastal protection. Mangroves provide coastal protection by reducing wave energy, resulting in reduced coastal erosion, erosion of sea dikes, and flooding. Mangrove forests often form typical band-like zones of different mangrove species that provide coastal protection. Erosion control. Fourth, mangroves stabilize shorelines and minimize coastal erosion by reducing wave height and energy of waves, preventing sediments from being carried away from shores. Thus, mangroves provide erosion control through sediment stabilization and soil retention. Mangrove engineering. The coastal protection provided by mangroves has been very effective. It is for these reasons that many countries, subject to such natural disasters, have mangrove planting programs to protect its properties and people. These measures are taken in anticipation of real threats from more frequent and stronger typhoons and at predictable times as a result of climate change. We have seen the regulating ecosystem services of climate regulation by carbon storage and sequestration, water purification through pollutant assimilation and nutrient filtration, coastal protection through wave attenuation, and erosion control through sediment stabilization and soil retention provided by mangroves, and how important these services are in mitigating or lessening the effects of natural or man-made disasters. The benefits humans get from mangroves are invaluable. If these services were evaluated in terms of its monetary value, it comes out to millions, even billions of dollars, second only to coral reefs. Yet, in spite of this, mangroves are still among the most threatened and the least appreciated ecosystems. It is our fervent hope that awareness of the valuable ecosystem services mangroves provide us would encourage you to know them better and assist in efforts for their proper management. Thank you for your attention, and we look forward to sharing with you more interesting aspects of estuarine and mangrove ecology.